Over a 30-year career, he changed the way people thought about chemistry. He was one of the world's first and greatest mythbusters. He's considered the father of modern chemistry. Meet Antoine Lavoisier. Lavoisier was born to a wealthy French family in 1743. Chemistry was kind of a mess when he started learning about it in school. Teachers were still using the ancient Greeks' ideas that earth, air, fire, and water made up everything around us. This seemed odd to Lavoisier, so he devoted his life to updating chemistry. He perfected laboratory procedures so scientists could more easily reproduce each other's methods. He named and described elements we take for granted today. Oxygen and hydrogen, a big deal, being the 7th and 8th elements discovered since record-keeping began. He also predicted the existence of other elements, such as silicon. And Lavoisier came up with a new way of consistently naming compounds. So when an element combines with oxygen, for example, it becomes something we call an oxide. Chemists today still use terms that Lavoisier invented to describe elements and compounds, and they still follow the systematic approach to science that Lavoisier championed. For these reasons and more, many call him the father of modern chemistry. Lavoisier was also the first to describe something called the law of the conservation of mass. That means that regardless of what chemical reaction occurs, the mass of the starting materials will be exactly the same as the mass of the products. This logically makes sense because matter cannot be created nor destroyed, so its mass cannot change. It's conserved. Later, this law would lay the foundation for our understanding of atoms and molecules. Many of Lavoisier's insights came from his work with gases. At the time, there was a lot of confusion and debate about what was in the air around us. Scientists had wacky names to describe the invisible stuff in air. There was pure air and inflammable air and phlogisticated air. That last one came from an idea that a substance called phlogiston was responsible for combustion. According to that theory, something that burns, say a piece of charcoal, contains its various ingredients and something called phlogiston. When the charcoal burns, the air around it absorbs the phlogiston and the air becomes phlogisticated. Fire, remember, was considered an element, so phlogiston seemed like a sophisticated way of chemically explaining flames. The phlogiston theory had a lot of problems. For one, when iron, for example, burns or rusts, the product has a greater mass. But if the iron loses phlogiston, how can the product's mass increase? Lavoisier was fed up with this foolishness. He wrote a book on phlogiston saying it was time to lead chemistry back to a stricter way of thinking and to distinguish what is fact and observation from what is system and hypothesis. This prompted Lavoisier to repeat experiments of Joseph Priestley. Remember, in proper chemistry, copying someone else's research is how you figure out what's naturally happening, not just making up some explanation. Priestley had been playing around with burning stuff and seemed to be onto something. In fact, he had isolated oxygen as a component of air responsible for burning, but he didn't realize it. Like Priestley, Lavoisier burned different metals and observed the products carefully. His results had Lavoisier realize that Priestley had discovered oxygen, an element from the air that combines with the metal to form a metal oxide, which is heavier than the metal itself. This proved that the mysterious component necessary for combustion was not phlogiston inside the starting material, but surrounding oxygen from the air. This insight showed that real stuff, heavy stuff like iron or invisible stuff like oxygen, can combine to make new stuff. Having vanquished phlogiston theory, Lavoisier wrote the first modern chemistry textbook, which included a list of elements known at the time, simple reactions between acids and bases, and his law of the conservation of mass. At his side through all this was his wife, Marie-Anne Pierret-Polzy. They married when she was only 13 years old, and she was his partner in scientific discovery. She learned English and German and translated the latest scientific papers by Priestley and others into French for her husband, meaning she had to understand all the concepts for proper translation. She recorded data and results from her husband's experiments and made meticulous drawings of the apparatus he used. Unfortunately, Lavoisier was sent to the guillotine during the French Revolution because, well, he had this side job helping the king collect taxes. He was just 50 years old. But his widow, Marie Anne, carried forward his legacy, throwing parties for the top scientists of the day, where they could present their latest findings and argue about how the world works. In his short life, Lavoisier managed to burn down old, incorrect ideas that came before him and build a new foundation for modern chemistry. So if you're feeling generous, take a minute to remember him next time Father's Day rolls around. Maybe you can light a cozy oxidizing reaction in his honor.